Hi everyone and welcome to Basic Understanding of WiFi6 session hosted by UC Corporation. Let's get started. In the last few decades, there's been a humongous growth in the number of internet users, devices, and the demand for connectivity. All these factors, coupled with digital transformation across industries globally, have contributed to the requirement of faster and ubiquitous wireless connectivity. To address these, Wi-Fi Alliance, the organization responsible for conceptualizing, developing, and certifying Wi-Fi standards, announced the next generation of Wi-Fi, Wi-Fi 6. Let's move to details. And here's a brief introduction of what Wi-Fi 6 is. The next generation of wireless networks based on 802.11ax is a development over the current fifth generation of Wi-Fi known as Wi-Fi 802.11ac. It operates in the 2.4 to 5 GHz band and can achieve a maximum speed of up to 10 Gbps. Wi-Fi 6 can achieve speeds which are up to 4 times faster than the previous Wi-Fi standards, promising better user experience and performance of bandwidth-consuming applications such as voice, video, and collaboration. The theoretical maximum transfer speeds are about 10 Gbps, but the commercial viable speeds are yet to be known. It brings an increased capacity, optimized spectral efficiency, and increased coverage, while reducing power consumption and latency across both the 2.4 GHz and 5 GHz bands. Let's move to the key features of Wi-Fi 6. It promises excellent performance in hyperdense environments such as malls and stadiums. The underlying technology of Wi-Fi 6 makes it perfectly suited for new age applications such as smart homes, Internet of Things, and smart manufacturing with better power efficiency. Wi-Fi 6 helps achieve faster data delivery with very low latency. This is possible through the use of OFDMA, which is orthogonal frequency data multiple access. And by using MU-MIMO, it can support a greater number of devices at once with greater speeds split across the network. What are the key features of Wi-Fi 6? According to wifi.org, these are the most important features of Wi-Fi 6. The first in priority is OFDMA, uplink and downlink, with transmission scheduling being rated as the second most important of all. I'll give you a minute to go through this slide. Moving on. Let's come to the key technologies which form the basis of Wi-Fi 6. I call them the Super 4. Wi-Fi 6 promises a variety of improvements and fresh features that drive Wi-Fi devices towards higher operational efficiency. These improvements are made possible by some of the key enabling technologies that bring enhanced performance even in demanding environments. Let us have a quick look at them. OFDMA, uplink and downlink orthogonal frequency division multiple access. This aids in increased efficiency and low latency. On Wi-Fi 6, devices can stay connected together to support more access points. Transmit beamforming. This is to enable higher data rates and to increase network capacity. 1024 Quadrature Amplitude Modulation Mode QAM. For increased throughput over bandwidth heavy applications, MIMO enables access points handle greater numbers of devices simultaneously. It operates across the 2.4 and 5 GHz simultaneously. So here are some key use cases that Wi-Fi 6 can drive. Wi-Fi 6 brings network performance up to a platform that will enable innovative and revolutionary applications in virtually every segment and industry globally. Some of the use cases and applications that are already apparent are mobile broadband, transportation, enterprise environments, smart cities, residential homes, IoT, high-density deployments such as stadiums and airports, retail stores and malls, entertainment units, smart cities and villages, and manufacturing. Okay, so we've known a lot about Wi-Fi 6, but what about the devices? What about the demand for devices? A report by ABI Research says that 802.11ax or Wi-Fi 6 chipsets are forecasted to reach more than a billion annual shipments by 2022. The report also gives an insight into the major driving forces behind the introduction of Wi-Fi 6. They are enormous growth in Wi-Fi enabled devices, increased per user traffic demand, greater number of users per access point, increased cellular offloading, higher density Wi-Fi deployments, growing use of outdoor Wi-Fi, heterogeneous device and traffic types, and a desire for more power and spectral efficiency. All the Wi-Fi generations till now need new hardware upgrades. Customers need to procure new mobile phones and devices which are compatible for Wi-Fi 6 in order to experience the next generation of connectivity. Here are some supporting devices of Wi-Fi 6 currently available in the market. Netgear, TP-Link, Samsung Galaxy, Asus, Dell laptops are some of them. These are about to increase as FCC has also released an additional broadband 6 GHz to bring in more devices. What are the key benefits of Wi-Fi 6? Here's listing some of them. Increased capacity and data rates. With 1024 QAM, Wi-Fi 6 has the ability to deliver a 25% increase over the previous generation of 256 QAM. Simultaneous multi-user support, which is possible through MIMO and OFDMA. This allows more devices to connect at once, thereby reducing congestion. Improved power efficiency. A very exciting feature which is a part of Wi-Fi 6 is a target wait time, TWT. This allows devices to plan communications with the router or access point in advance, which helps improve battery life. Performance in hyperdense environments. Multiple access points deployed in dense environments deliver the desired quality of service to clients which have diverse usage profiles. Thus, Wi-Fi 6 is perfectly suited for high-density venues such as stadiums, auditoriums, retail chains, and malls. Let's have a look at some key deployment scenarios of Wi-Fi 6. Public venues, stadiums, theme parks, which are all hyperdense environments. These receive a very high footfall every day, and thus the population density at these venues is very high. This requires the base station at these places to support a high network bandwidth requirement from users. Wi-Fi 6 improves the efficiency of the spectrum, thereby enabling concurrent usage and increased bandwidth requirements. Since these venues may experience a sudden rise in voice traffic on Wi-Fi networks, Wi-Fi 6 can handle latency efficiently. Wi-Fi 6 uses OFDMA, MU-MIMO for uplink and downlink, which helps support the increasing demand for video content, uploads and downloads from users in a hyperdense environment at a particular stance. Industrial IoT. There's a very exciting project which is taken by Wireless Broadband Alliance in industrial IoT space. The WBA and Metis Aerospace announced the world's first Wi-Fi 6 industrial enterprise and IoT trial. The use cases under this trial include multi-stream live video monitoring, real-time energy monitoring, ultra-reliable low-latency communications with sensors on critical systems, and the use of augmented reality. Smart cities. The capabilities of Wi-Fi 6 in terms of high capacity support and increased throughput have had significant benefits in the deployment of smart cities. The increased throughput through Wi-Fi 6 is significantly important for enabling wireless backhaul scenarios within smart cities network. Congestion planning for smart cities network can be simplified through the use of Wi-Fi 6. The benefits of the frequency reuse feature in it facilitate spatial efficiency and allow access points to be moved closer. This increases the overall network capacity with a higher density of access points for a given number of users inside a particular cell. Over 525 billions of economic value has been attributed to Wi-Fi technology in US alone, and this is forecasted to exceed $850 billion by 2025. Wi-Fi 6 commercial deployments will aid in laying a robust foundation for Industry 4.0 globally. It would be a solution for the ever-increasing demand for faster data rates over wireless networks. The benefits of Wi-Fi 6 will be seen over time as more devices and OEMs support the standard and build affordable consumer products around it. Are you interested to know more? Contact us at info@hsc.com. Until then,